We've been looking at how to factor trinomials with a lead coefficient of 1. So we're going to keep doing that, except we're going to extend it to something called solving quadratic equations. Because here we have a quadratic that is a polynomial with a degree of 2, except this time we're not just asked to factor it, but rather we have an equation. It equals 0. So therefore what's implied here is we're being asked to find out x equals what? And how do we do that? Because right now I have both an x squared and an x term, which makes it difficult to just solve for x. Well, just like we have seen before with binomials, we're going to solve this by factoring and then use the zero product property. So I want to factor this first, which, since it's a trinomial, I'm looking for factors of negative 18 that add to 3. And you can create a nice little chart over here and put one side as factors, so two numbers that multiply to negative 18, and then over here the sum of them, and this one needs to go to 3. So let's start from the top. I can have 1 and negative 18. Multiply those together and you get negative 18. Add them together, you get negative 17. So that's not going to work, but what if I try negative 1 and positive 18? Again, because I'm trying to find factors that multiply to negative 18, one or the other can be negative. When I add these, it's 17. All right, what about 2 and negative 9? Add those, it's negative 7. 9, keep the 2 over here, negative 2 and positive 9. Well, that's a positive 7. I've got another one, though. 3 and negative 6. Well, that's negative 3 when I add them together. And then one other factor, negative 3 and positive 6. Add those and you get a positive 3. So it took us going through all the factors until the last one worked. Because negative 3 times negative 6 multiply to negative 18, but add to 3. So I can factor my trinomial as x minus 3 times x plus 6 equals 0. Remember that equals 0 because that's essential to what we're doing here. So I was able to factor my trinomial of this form, x plus a number times x plus a number, where those two numbers, negative 3 and 6, are two numbers that multiply to your last term but add to your middle term. Now I can apply the zero product property to finish out solving this because I have two things being multiplied together that equal 0. So I can say either x minus 3 equals 0 or x plus 6 equals 0. I take each of those factors and set them equal to 0. And then I solve each one. Add 3, add 3. So either x equals 3 or x equals negative 6. So I have two answers there, 3 or negative 6. Because if I plug either of those numbers into the top equation, the left will equal the right, and we'll have a correct solution. So we factor, and then we set each factor equal to 0. Okay, let's try this one. We're asked to solve x squared plus 6x equals 27. Now when I see a problem involving x squared and an x, I know I have to solve this by factoring. And whenever I solve something by factoring, you have to set it equal to 0, because you have to be able to use the zero product property, and that only works if the equation is set equal to 0. So the first thing I'm going to do is subtract 27 from both sides. So I get x squared plus 6x minus 27 is equal to 0. Now I'm going to try and factor this trinomial with a lead coefficient of 1, which means it's going to be of the form x plus some number times x plus some number equal to 0. Where what are those two numbers? Well, they are two numbers that multiply to negative 27, that is factors of negative 27, but add or sum up to 6. So negative 27. Well, I have negative 9 and positive 3, but those add to negative 6. So maybe if I flip around the negative signs, 9 and negative 3, those would add to positive 6. So it looks like I've found my numbers. So x plus 9 times x minus 3 is equal to 0. By the zero product property, The solution here is either x plus 9 is equal to 0 or x minus 3 is equal to 0. Solve each of those and you get x equals negative 9, x equals 3. Once again, two solutions, x equals 3 and negative 9. You should continue to expect two solutions whenever you're solving a quadratic. And that two solutions comes from this idea that it's x squared. Because the highest power is 2, you're going to have two solutions. Sometimes one of those solutions is repeated, and you might get x equals 3 and 3, so you only actually have one unique solution. However, you can expect there to be two solutions with a x squared equation. Lastly, we're asked to solve z squared minus 3z equals 70. All right, let's use our zero product property, which means set it equal to 0. And because I have an equal sign, this is telling me, hey, I have to find what x equals. I'm not just factoring, I have to find what x equals. So I factor this trinomial, factors of negative 70 that add to negative 3. Well, let's see, I have negative 70 and 1, so that would be negative 69. I'm not even going to worry about the switching to negatives because that's way too big for our negative 3. Let's take it down a notch. What about 10 and 7? 10 and negative 7. Add those and you get positive 3. So let me flip that around. Negative 10 and positive 7. That gives me negative 3. Looks like I have found the two numbers that multiply to negative 70 but add to negative 3. So I can factor this as z minus 10 times z plus 7, where the negative 10 and 7 are those two numbers I found. By the zero product property, if I have two things being multiplied to equal 0, then either z minus 10 equals 0 or z plus 7 equals 0. So z is equal to 10 or z is equal to negative 7. Once again, both of those are possible solutions for this quadratic equation.